and give kudos to the 5 or 6 people that have actually started their homework. All right, we are recording, and I'm going to move on to Unit 3, 3.3 and 3.4. Well, before I do that, let me go over something right quick for you. The Chapter 3 test and the Chapter 4 test will be this weekend. Okay, both of them will be this weekend. I'll assign them just like last time on Friday, and they'll be due on Monday. Okay. Chapter 3, I would say probably 70% of Chapter 3 is going to focus around quadratics and completing the square. Now, what I mean about quadratics, I mean vertical, horizontal shifts, vertical shift, horizontal shift, orientation. Completing the square, then vertical shift, horizontal shift, orientation, or sketch the graph like we did the other day. And it might ask for domain, range, increasing, decreasing, and line of symmetry. Okay, now what I'm trying to tell you is on the Chapter 3 test, this is what it's going to focus around. Okay. That's 3.1 and 3.2. The rest of the test is going to be pot shots out of 3.1, 3.3, 3.4. Let's see what the title is on 3.9. No, I don't like 3.4 that much. Probably 3.3 and 3.5. So the other 30% will come out of 3.3 and 3.5. You might have one question out of 3.4. One question. We're going to go over that today. So that's what that looks like. And then the Chapter 4 test is kind of a continuation of Chapter 3. And then it's going to move into functions and composition of functions. And / one-to-one functions. Okay, so we're going to get into that later, but I wanted you to focus on 3.1 and 3.2, and that's what I was hoping everybody would do their homework on the last couple of days, but y'all didn't, so I guess we'll just move on. Now, 3.3 and 3.5. 3.3, we're going to be moving into cubic functions and functions, power functions, cubic and power functions. What is a cubic function? Well, a cubic function, your parent graph looks like this, and that's x to the third, and it's an odd because it is symmetrical around the origin. And your x to the fifth will look a little bit flatter on the turns because it's x to the fifth. X to the seventh be a little bit flatter. Ooh, I messed that one up. The higher the degree of your odd functions, the more flat this area right here is going to be. That's supposed to be going through the origin, but I didn't do so well going through the origin. Anyway, x to the ninth would be even flatter than this one. And eventually you get to where you have hidden behavior and you have a max and a min. And we'll get into that later also in chapter 4. So how do you solve these? Well, you solve them using the cube root or take the cube or cube. You also rewrite. You can have functions that look like f of x is equal to x to the third power. You can have f of x is equal to x to the -1 power. And you can have f of x is equal to x to the -2 power. And you're going to change this to 1 over x. And you're going to change this to 1 over x squared. So you can rewrite some of these because of the negative. And that way you have a function. This function is your parent graph. You need to put this in your parent graph if you haven't. This function looks like a half a volcano. And this function looks like a volcano. So you're starting to get into, upper level functions to the third, to the fourth, to the fifth, and your x to the negatives can be rewritten, and that gives you a rational expression, which gives you a different type of graph. Okay, now the rest of 3.3 is solving. Okay, so we're going to go ahead and look up some problems and do some solving. Really not a big deal. Most of you have seen these before in Algebra 1 or Algebra 2. So you should be okay as far as 3.3. So let's go ahead and look at some problems. So go to 3.3 and let's just look at preview. And let me find a couple of test questions that I would put on the test. Here's one. Determine if the following function is concave up or concave down in the first quadrant. Well, first of all, what the heck are you looking at? Well, it's f of x is equal to x to the 4/3. Now remember, most of the problems in 3.3 are going to be problems that are not x to the second power. So you got to know what to do with problems that are not x to the second power. Well, first of all, this is a rational exponent. And as I told you before, exponent over what? Exponent over index. So this is really the third root of x to the 4th power, which is actually the third root of x to the 3rd power times x to the 1st power, which is equal to x times the cube root of x. Now, when you look at this, you should be saying to yourself, oh yeah, I remember that. Okay? Most of you should be okay with that. God, we lost somebody. We only got 12 now. What happened? Somebody left. That's pretty sad when somebody leaves class. I don't understand why people are not here today. Is it some kind of holiday today? Y'all settle down, please. All right, so you can graph this on your handy-dandy calculator. So let's go to our handy-dandy calculator, and let's see what it looks like. I don't know if they want to simplify it or not. So f of x, y is equal to x to the 4/3, x parentheses, caret symbol, parentheses, 4, and then 3. 4 divided by 3. And get rid of that. Let me give y'all a hint, the word of advice when you're dealing with these new calculators. Always clear the, because when you use delete, it'll mess you up. Okay, there we go. And graph. And you can see that it's concave up. It's opening up. And I'm going to do a zoom 0. There you go. So it's concave up. And so what did I just show you? I showed you how to graphically put in the problem, and I showed you how to algebraically manipulate the problem. This is algebraic, and of course the graph looks like this. Kind of a V. Looks like that. So that's a good test question because it's short and sweet and to the point. And I can't find my problem. Where'd my problem go? Did it just disappear? I guess it did. There it is. So it's concave up. Good test question. Next. Let's look at some more. That might be a test question. That's a calculator drill right there. So you should be able to do that with the calculator. That's a calculator drill also. Want to find a solve equation. That's what I want to find. Okay, here's one. Solve the equation. So we got 4x to the third power equals 468. Let me make it a little bit bigger. Well, I can't for some reason. I can't make it bigger. So 4x to the third equals 768. Give y'all a second to work on that. And let's see, this class is over at 11:40, and right now it's 10:20. So 11:40 would be an hour and 20 minutes. So we'll just cut it off at an hour and 5 minutes. If we make it that far. We might just go ahead and get everything knocked out today. Got plenty of time. And nobody says anything. So divide by 4. Divide by 4. X cubed is equal to 1. 4 will go into 36. What? 9 times? And 2. Y'all check my math. 192? Yes or no?
Yes.
And take the cube root. X is equal to the cube root of 192. Now, some of these problems, they may want approximate. Approximate is done in a calculator. What if they ask for exact?
You have to be exact.
Exact is done with what? Radicals. So I'm just going to assume that they're going to want done radicals, because that's the way these questions are. Let's see. Can we divide anything into 8? No, can't divide 8 into that. I'm looking for, yeah. We can take the cube root of 4. 4 will go in there, but that's not going to help us because our first cube root is 8. Cube root of 8 is 2. the cube root of 81. There it is. No, not 81. 81 won't work. Cube root of 81 is 3. So I don't think we can do anything with this. I'm trying to break it into radicals, but we can't. So I don't know. Let's see what they get. Solution is the cube root. Let's see if they want a cube root. Cube root of 192. Evidently, they want to break it up into its multiples. And I'm just going to see. Okay, there is a cube root that can break it up. Wow. Let's see what that is. 4 cube root. 4 times 4 is what? 16?
Yeah.
64? 64, yep. 64 times 3. I didn't go far enough. Cube root of 64, yeah, is 4. And 81 is not 3. 3 times 27, dork. 64 is 4. So that'll break up into the cube root of 64 times the cube root of 3, which is equal to 4 times the cube root of 3. So there you go. Knocking some cobwebs loose, I hope.
Yeah.
All right, let's keep going. That was a test question. Okay, here's one. 5 times 3x minus 2 to the 4th power is equal to 1280. Now remember, I told you these were probably going to be pretty simple to you because, like I said, they're, you know, they're just powers. Mr. King, y'all gonna cut the tree down? Is that what y'all gonna do next? You're gonna need more than a weed eater to cut that tree down.
We got chainsaws.
What? I
I
couldn't
think he said he has
hear.
chainsaws.
Divide by 5. Divide by 5. 3x minus 2, quantity to the 4th power, is equal to, 5 will go into 12 2 times. That'll be a 10. That'll be a 28 5 times. And 6. Somebody check my math, please.
That's correct. 256.
Now, you can take the 4th root or you can raise it. I like to do this because this seems to help people out rather than taking the 4th root. Raise it to the 1/4 power. That might help you out with the calculator a little bit because 256, I believe, is a 4th root. So take your handy dandy calculator and raise 256 to the 1/4 root, or 0.25. That 4th will cancel out that 4, and that leaves 3x minus 2 is equal to, did somebody take the 4th root of 256, or 1/4 root? What is it? That's all right, I'll do it. What?
4. 4.
Thank you. Got to speak up. Dang old articulate. Whoever that was, I don't know who that was, but Miss Taylor's done fainted. She fainted, and all we can see is the ceiling fan. All right, add 2. While the King brothers are still trying to figure out how to cut that tree down with a weed eater. 3x is equal to divide by 3. X is equal to 2. that what y'all got? Why is everybody so dead this morning? Why? What's up?
Yes.
Miss Garcia, why is everybody so dead this morning?
I don't know, but I'm feeling it too.
Mr. Brooks, you need to quieten down, please. All right, what else? Anything? Looks like that's it. X is equal to 2. Good test question. Why is it a good test question? Because that's what this section is on. We got something wrong. Did y'all check my math?
I want to type in 86.
What?
Check 86. See if that works.
Well, I must have done something totally wrong.
Huh.
I don't know what's wrong. 2 and negative 2/3.
The hell? That's weird.
Okay, I have no idea what they're doing here.
I don't either.
Oh, I know. Fourth root can be a positive or a negative. They're including the positive or the negative. That's why.
I didn't include the.
So the fourth root can be a positive or a negative. So that 4 could be positive or negative. And we need to put that in there. We need to highlight it because that's something we all forget to do. And we do it with a square, but we forget to do it with a cube, with a fourth root. Right here, we forget to put that in front of the 4, because negative 4 times negative 4 times negative 4 times negative 4 is positive 256.
Oh, yeah.
And positive 4 times positive 4 times positive 4 times positive 4 is 256. We do that when we take the square root and we don't even think about it. But when we take the fourth root, we just forget about it. Just like I did. So this is going to be 4 plus 2 is 6. And 6 divided by 3 is 2. Or negative 4 plus 2 is negative 2. And negative 2 divided by 3 is negative 2/3. Is that a common mistake? Yes, people make that mistake all the time. Make sure you put a positive or negative right there. Okay, let's move on. Move on to something a little bit different. Okay, there's a variation. Let's see what that one says. Suppose that S varies directly as 2/3 power of t. Well, first of all, direct variation. What is direct variation? We learned that in the review. Direct variation is y is equal to k times x. And what letter never changes? I told y'all this in the review. What letter never changes? Okay. So that means S is equal to K. Well, that's going to be 2/3 power of T. So that's going to be K times T. Is that a capital T? To the 2/3. Looks like. Now, they want to know what S is when, well, they say, and that S is equal to 75. And T is equal to 125. And then they want you to do a second part. 2/3. So 75 is equal to k times, well, the third root is 5. Let's see, that's exponent over index. So the third root of 125 is 5, and 5 squared is 25. Somebody check my math. And divide by 25, and k is equal to 3. Check and make sure what is 125 to the 2/3 power. See if it's 25.
3 is correct.
I'm sorry, what?
3 is correct.
Okay. Uh-oh, the King brothers, where are they at? I want to make sure they didn't try to cut down that tree yet. Oh, look at them. They done cut down the tree and knocked them out, and their phone is facing the dirt. So I knew that was going to happen. And one of them's gone. One of the King brothers is gone. I hope the tree didn't fall on him. All right. So now we take this 3, and what do we do with it? Back substitute. And now we get S is equal to 3t to the 2/3. And they say find S when t is equal to 27. And the cube root of 27 is 3. And 3 squared is 9. 9 times 3 is 27. Y'all check my math. That's another test question. Well, both King brothers are still in here. Just one video is not on. So I don't know. Maybe they're still alive. I see movement. Did somebody check it for me? 3 times 27 to the 3rd power.
That's right.
And that's 27. Okay, that's a good test question. Let y'all do this one. I wish I could blow it up, but I can't. Suppose that y varies directly as the square root of x, and that y is equal to 16 and x is equal to 16. Find x when y is equal to 32. I don't understand why I can't. I bet I know why, because I'm in review mode. I bet that's why I can't. I'll have to get out of review mode. So suppose that y varies directly as the square root of x. So that would be y is equal to kx. And we're not going to change any of the variables, but we're going to say y is equal to k times the square root of x. Y is equal to 16, and x is equal to 16. So 16 is equal to 4k. K is equal to 4. Back substitute. And they say find x when y is equal to 32. I got x is equal to 64. What'd y'all get?
That's what I got.
We are confident in ourselves, so we don't have to wear sunglasses indoors. Remember that, girls. If you ever see a guy wearing sunglasses indoors, run the other direction, because that's future domestic abuse.
Or driving a squatted vehicle.
What?
Or driving a vehicle with a squat.
Yeah, that's domestic abuse. 5-10 years down the road.
Mm.
All right, because you didn't make him a sandwich when he come home from work. Yeah.
Mm.
Yeah, I just said that. There are people like that. Next. Or you do like the dude a while back that the mother / girlfriend went by and got pizza for the girls. They had 2 girls, and they didn't bring him some. They come home and they were eating pizza, and he shot all 3 of them. Yeah, because you didn't bring him any pizza. They're cavemen. They're out there. Number of females in engineering, blah, blah, blah. Where X is the number of years after. Okay, let's look at this one. The number of females in engineering continues to show a steady increase. The number of female engineers in a certain country can be modeled by the function. You're going to write that down because you're not going to get by without using that function. So f of x is equal to 0.679 x to the 1.227, where x is equal to the number of years after 1950. And f of x is the number of female engineers in thousands. F of x is number of FE in thousands. Okay. A, what type of function is this? Well, it's a power function. It's raised to the 1.222. It's a power function. So graph it, it's going to look like a power. Okay, plug in f of 20. So A is the power. B, f of 20. And C, how many female engineers will there be in 2030? All right, so get to work. I gave you A. This is a power function. But go ahead and do B and C. I'm going to switch over. No, I better not, because it'll change the question. I'll wait after we do this one. I'm going to switch over to what it really looks like, and maybe I can blow it up a little bit. This is an exponential power function. F of 20, so I'm going to plug in 20. So that's going to be 0.679 times 20 to the 1.227 power. And take your handy dandy calculator out. And clear. 20, caret symbol, 1.227, multiplied by 0.679. 26.806. 26.806. So that means the question said, what is f of 20? Well, that means 20 years from what? 1950. In 1970, there is 26,000 engineers. pretty much, or close to 27,000. So I don't know if they want it in deaths. Okay, it says round to the nearest thousandth. That's what we did. 26.806. This means that there were 26,806 female engineers in 1970. There will be blank female engineers in the country in 2030. All right, so let's do that one. 2030 minus 1950, 13 minus 5 is what? 8? Y'all help me out here. And that's 80. So X is equal to 80. Therefore, 0.679 times 80 to the 1.227. That's what I got. 80, caret symbol, 1.227 equals times 0.679. 146.880. 146.880.
You have a work email.
So in 80 years, well, in another, what, 9 years, 146,880 women will be engineers. 146,880. More power to them. I was a civil engineer major to my second semester junior year, and I loathed it. I could not stand going to class. Hey, kitty cat. I believe Miss Taylor has just given up. She just threw her phone across the room and she's just given up. Black cats are special. All right, so anybody got a question on that one? That's a good test question. Y'all settle down, please. I'm trying to teach. You know, y'all could say something. I mean, it would help to say something. Nobody has anything to say today. It's just, okay. I'm going to see if I can blow it up now that I'm going into the, I don't know which problem that was that we just did. Yeah, we already did these. I just did number 36. Oh man, I just did almost all of your homework problems. All right, here you go. And I can't blow this up either, so I have no idea why I can blow some things up. The U.S. population can be modeled by the function blah, 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 where y is in thousands since 1800. Oh, well, this will help us in the world, because Al Gore said that the world was going to be gone by 2000. Yeah. So,
Yeah.
and then we've had some other people that say we only have 12 years left. Y is equal to 165.6 x to the 1.345. And x is equal to the number of years after 1800. What was the population in 1950? What is the population in 1950? B, is this graph concave up or concave down? Whatever. B, concave up or concave down. And C, use numerical or graphical methods to find find out when the model estimates the population was 93,910,000 people. Okay, so there you go. There's the problem. I'm going to give y'all a minute to work on it. And if I'm not depressed because my math class won't speak to me, Dogecoin is down to 33 cents. So I'm really depressed. Damn Russians. That's who did it. Y'all ready for this? One of my calculus students told me they weren't going to be in class today, wanted me to email them and tell them what we went over in class. Am I going to reply to that student?
No.
L to the no. Nope, I just record these videos for my health. There is Autumn. Is Autumn helping you out with these problems?
No, she's not much help. She's beating me up.
She says, the heck with this stuff. Okay, so 1950, so X is equal to 150 years, right? Therefore, 165.6 times 150 to the 1.345. So take our handy dandy calculator. Clear. Clear. Are y'all like me? You got to clear it before you start. Any OCD people out there?
Yeah, I do that too.
I got to. All right. 150 raised to the 1.345 equals times 165.6. And the population in 1950 was 139,927.5003. Poor old ratio. 139,928. Now, why did I automatically raise that up? Because you need to watch the Andy Griffith episode about Opie given to the charity fund. Poor old Horatio. There's no such thing as a ratio of a person. So since that's a 0.5, you round that up to 28 people. Now, somebody tell me what this looks like. I don't see a negative anywhere, but let's go ahead and let's do it. Let's put it in the calculator. Y is equal to, or graph is equal to, and this Y is equal to, clear this, and that's going to be 165 0.6 times x to the 1.345 and graph and zoom O, and it's concave up. I'm going to zoom out a little bit. Any good movies lately?
No,
What?
none.
None.
80s
Why is
movie.
it all positive? Because you can't have a negative population. That's why. So it's concave up. Why is that significant? When would you have a population concave down?
When people are
Dang
dying.
old nuclear war?
Yeah.
What?
Yeah, when people are dying in mass numbers.
Exactly, it'd be decreasing. Population, according to human nature, should always what?
Go up.
Go up. Unless, you know, you have leadership that destroys everything and makes it go down. Next.
The Germans know something about that.
Don't say German, you get in trouble.
So do the Japanese.
Next. Oh, that's it. That's all your homework. I just did the last, what, 2 or 3 problems of your homework, which some of y'all won't do. So anyway. Let's look at piecewise functions. And the best way to explain a piecewise function is to just do them. So I'm just going to do them. And I hit the wrong button. Sorry. 3.4 homework. And I usually don't do this, but with these 2 sections, the best way to do it is to just show you some homework problems. Because I'm not introducing anything really new, like completing the square to some people. So 3.4 is piecewise functions. And just to let y'all know, I went through and changed this homework because they were going over a lot of stuff that was not necessary. You're welcome.
Okay, you said something about that yesterday. I remember that.
Oh, you looked at it? There was about 3 times as many questions. I kind of narrowed it down a little bit.
About that yesterday, stuff that we hadn't covered.
What?
I remember you had said that yesterday. There was stuff that we hadn't covered.
Yeah. All right, I want you to write this one down. I can't make it bigger for some reason. I don't know why. But write this. This is a piecewise function. So y is equal to x squared minus 4. And that is x is less than or equal to 0. And I'm going to do that in another color. Let's do that in green. X squared minus 4. And x is less than or equal to 0. And then we'll do the other in lilac. X cubed plus 5. And x is greater than 0. All right, I want you to graph those 2 on a piece of paper. Graph those 2 on a piece of paper. Give y'all a minute or 2 to do that.
already one message coming in on secured.
Now, I'm going to show you a little trick I learned in the war. Take your handy dandy calculator. Y is equal to x squared minus 4. Oh, Lord. Hold on a minute. Can't hit the right button. Minus 4. And then I'm going to put a division symbol. And I'm going to type in x is less than, parentheses, x math. Where is my... No, it's not math. Which one is it? It has the... Hold on a second. Give me a second. Until I don't use calculator very much. I can't remember which one has the less than or equal to. Does anybody want to help me out?
I do not know.
My son knows I'm in class right now. Oh,
Gmail.
come on. Which one is it? Hold on. I'm going to have to make this bigger. I can't see. Let me answer this. He's at school and there must be a problem. Hold on just a second. Sorry about that. He's taking a test. All right. And I got to go get him. Oh, come on, Hubert. Where is it? I pull this stuff up all the time. It's not second angle. It's not angle, is it? Nope. Apps. Nope. Math. I thought it was math. And I guess it's not. Nope. Oh, come on. Give me a second. I can't find it. There's a button that you hit, and I can't find it right now. And it gives you the less than or equal to. And I'm so frustrated right now. I can't believe all y'all just graduated high school and I figured they taught y'all how to twirl this thing around on your finger like a basketball. And I can't find it. I thought it was math or apps. But I guess I'm crazy. Let me do lists. No. Second bars. I can't find it. Anyway, there is a button on here that you can actually do less than or equal to, less than, and I can't find it right now. I guess y'all think I'm crazy. Has anybody got any idea where it is?
I have no idea.
Okay, well, I'll find it later. I can't find it right now, but you can actually graph this on your calculator. I don't know why I can't find it all of a sudden. Maybe if I wouldn't get 15 phone calls while I'm trying to teach, it would help me out tremendously. All right, so here we go. We got a graph, and we got x squared minus 4. Negative 4 is your y-intercept. So that's right in here. 1, 2, 3, 4. And we know it's opening upward, but we cannot use any of these numbers right here. We can only use the left side. So there's that function. Okay? We can only use negative numbers. We can use 0, but we can't use positive numbers. We can use negative numbers. And then the blue is, we know that the y-intercept is plus 5. We cannot use 0, so that's going to be an open circle. And we know the cubic function looks like this, so we're going to give it kind of a, like that. And that should be what it looks like. Now, I am kind of aggravated because I couldn't find I'm looking, that irritates me. Hold on. I'm going to find it. Give me a second. Second math. Let's try second math. I knew the math button was it. Second. There it is. I must have not hit it twice. Second math. So go back to your y is equal and do second math. I don't know why it didn't come up when I hit it a while ago. Like I said, them damn Russians. 0, close parentheses, and I want to change that color. I'd like to change it to green, but I tried to change it the other day and I couldn't change it. There's green. Some of y'all didn't even know y'all could do this, did you? That's okay. And y of 2, we're going to do that in blue. Kind of a light blue. There we go. And that's going to be, what's our other one? X cubed plus 5. X cubed plus 5. Plus 5. Division symbol, parentheses. X is greater, second math, greater than 0. Y'all got it? Okay, mine don't look like, look at this Zoom standard. Zoom standard is 6. There we go. That's what it looks like. And you can see that you're drawing should not be too far off. Question, gripe, complaint?
No.
Any questions on that? I can't take this. Y'all too quiet. This sucks.
No.
Thank you for the little no. I appreciate that. Thank you. And that's how you do a piecewise function. Now, what's f of -1? Well, f of -1 is going to be on the green line. Watch this. Now, this is where y'all get screwed up. F of -1. It says, what is f of -1? Well, where is -1? -1 is right here. Well, that's on the green line because there's nothing up here for the blue line. So it'd have to be on the green line right there. So plug in -1. What's -1 squared? +1. 1 minus 4 is -3. So that would be -3. Now, I hate to be kind of simple, but I will tell you, this is where students freak out on tests. They see this, and they don't know what in the world to do. F of 2, go back to the graph. Where is x equal to 2? Well, it's right here. Where is 2? Is it on the blue line or on the green line? It's on the blue line, Hubert. Thank you, class. So you plug 2 in. 8 plus 5 is what, 13? Somebody check my math. Yeah, Hubert, that's right. No, Hubert, you don't know what you're doing. Thank you, class. Appreciate it. I'm going to start deducting points. If you don't talk in class, if you don't communicate in class, I'm going to take points off your test. This right here is a prime example of what I would give you on a test from 3.4. Okay? Question, gripe, complaint. All right, since my son is going to be sitting outside the school here, shivering cold, and DSS is going to come get me, I'm going to have to go pick up my son. All right? So, hopefully y'all won't have to worry about DSS for a while at least. But, you know, I have to because I'm the terrible father. So I'm going to have to go pick him up. Because, like I said, if I don't pick him up at exactly the right time, then somebody says that calls DSS and says that I'm a terrible father. No, I'm just kidding. Any questions? Let me take the roll right quick. I'm going to go ahead and Miss Garcia sitting there. He is a terrible father. That's what Miss Garcia just said. That's all right, Miss Garcia. I know that's what you're thinking. All right, so I'm glad to see that Miss Taylor finally